Okay, we're going to take a look at different number classifications so we can see how they relate to one another. We have two main number classifications. We have what we would call real. We have real numbers, and the symbol we use for that looks like an equal sign, R. So we have real numbers, or we have complex numbers. Okay. So an example of a complex number is anything that would have the square root of a negative number. That would be a complex number. So if I have the square root of negative 2, the square root of negative 1, or 3 plus the square root of negative 1. All along we've said, well, there's no real solution. That's because we have something called a complex solution. The square root of negative 1 is actually equal to something that we call I. I is an imaginary number. We write it with a tail, and so the square root of negative 1 is I. So 3 plus the square root of negative 1 would be 3 plus I. So every complex number has a real part. Sometimes that's 0. So we have a real part plus or minus the imaginary part. That's the part that has I in it. That portion always goes at the end. So we maybe have 3 minus 2I. Maybe have 5 plus 7I. Or maybe we just have 8I. The real part would be 0 in that one. So those are all complex numbers. And we're going to look at how to add, subtract, multiply, and divide those in this video. Real numbers, we have two different types. We have rational, or we have irrational. Now, an irrational number is a square root, can't be worked out. So be something like the square root of 8. Now, we know that that breaks down and that gives us 4 and 2, so 2 square roots of 2. But this portion can't be written as a fraction, and there's not an exact number. These are decimals that don't repeat or terminate. Pi. Pi is an example of that. Negative 2 square roots of 7 would be an example of that. Now, rational numbers, we also call that the quotient group. The quotient group is any number that can be written as a fraction. So those are your repeating decimals. Or your terminating decimals, like for 0.5. So that would be your 1/2, your 1/3, your 0.75 repeating, negative 5.1. Those are all rational numbers. Well, of the rational numbers, we have some special numbers called the integers. Now, our integers are things like -4, -3, -2, -1, 0, 1, 2, 3, and so on. They're positive and negative whole numbers. Now, these positive and negative whole numbers can be written as fractions, so they are also rational. They're also real. Within the integers, we have something called whole numbers. The whole numbers would be 0, 1, 2, 3, and so on. They're all positive, they're all whole numbers, but it includes 0. And then we have our very little piece here in the middle is our natural numbers. And those are the counting numbers. Those are the things you learned how to count with when you were a kid. We didn't understand 0 suckers, so that wasn't natural to a young kid, so it's not a natural number. So 2, or the square root of 4, is a natural number, a whole number, an integer, a rational, and a real. So those are our number classifications. Now let's take a look at the complex numbers, though. If I wanted to add 2 complex numbers, like, say I wanted to add 3 plus I, that's one complex number, has a real and an imaginary part, and I wanted to add to that another one, 6 minus 7i. Well, you add the real parts and you add the imaginary parts. So this is just like combining like terms. So I'd have 9 minus 6i. Now what if I wanted to multiply? So what if I had 5i times 3 plus 7i? Just pass it out, distribute it like you would. So you have 3 times 5 is 15i, plus 5 times 7 is 35, I squared. Now, let's take a look at this I squared. I squared means the square root of negative 1 times the square root of negative 1. Negative 1 times negative 1 is positive 1. Square root of positive 1 is equal to, actually, square root of negative 1 squared. We have to look at it as we have the square root. How do we undo the square root? We square it. So the square root of negative 1 squared is equal to negative 1. So that's a big one. I squared. So I is the square root of negative 1. I squared is negative 1. Well, I cubed, well, if we multiply that by I, so we would have negative I, because that's I squared times I, negative 1 times I is negative I to the 4th is I squared times I squared, that's negative 1 times negative 1, which is positive 1. I to the 5th, I to the 5th would be I to the 4th times I, total of 5. Well, I to the 5th, or I to the 4th is 1 times I, so I to the 5th is I. And you're kind of cycling back around, and that'll just keep going. So I squared, we found out here, I squared is equal to negative 1. So I would have 35 times negative 1 is negative 35 plus 15i. We always put the real part first and the imaginary part second. I want to do one more. What if I have to multiply 5 plus 8i times negative 2 plus 2i? So those of you who are FOILers, that's what you would do here. So you could FOIL, you could use distributive property, 5 times negative 2, which basically is 4, plus 8i times negative 2 plus 2i. And then we can multiply it out. You could use the box method. 5, 8i, negative 2, 2i. Do it that way. This is probably my favorite. I'm fastest at this one. So I've got negative 10. Negative 2 times 8i is negative 16i. 5 times 2i is 10i. 2 times 8 is 16i squared, which is really negative 16. Now I combine my like terms and get negative 26 minus 6i. Same thing here. Negative 10 plus 10i, negative 16i, plus 16i squared. This really becomes negative 16. Negative 16 is 6 minus 6i. So that's how we multiply and add imaginary numbers.